All right, we're looking at polynomial addition. It's just simplifying polynomials by combining the coefficients of like terms. Okay? Combine coefficients of like terms. And how do we determine what are like terms? What's the criteria? What has to match? Yeah.
They have to have the same variable and the same power.
Very good. Same variable and has to be both power or exponents. Same variable and the same power. That is a matching like term. All right, so one method is the horizontal method of simplifying these polynomials. That means we would have a polynomial plus another polynomial. Let's see what that looks like. All right, so here's our example. We have this polynomial on the left. This entire thing is one polynomial added to this trinomial. Okay, this is an application we could use addition in what measurement of shapes? Perimeter or area? Perimeter. So when you find the perimeter of something, you're going to add up all the sides. We're going to give you shapes defined by polynomials. All right, before we start combining like terms, let's get rid of these parentheses. How do I get rid of the parentheses here? I want to get rid of this parentheses. How do I get rid of it? Multiply by why 1? You're correct, but why? Yeah. To get the same thing, because there's an invisible 1 on the outside. To get rid of the parentheses, I would be, in my head, multiplying 1 times all those terms. Basically, what I'm doing is just getting rid of the parentheses. So it becomes 3x to the third. It stays 3x to the third, 2x squared, minus 5x, plus 7. Okay, all we're doing is getting rid of the parentheses. Do the same thing on the other one. Okay, so basically we're just rewriting this addition problem without parentheses. Plus 4x to the third, plus 2x, minus 3. Now we go through and gather all matching terms. Okay, but let's start in order. What do you mean by order? Start with what? What's our largest power in all of these terms? 3, the cube term, right? So do we have multiple ones? Yeah, so let's add those together first so we have our answer in standard form. All right, so let's go ahead and circle our x to the third terms. So we have 3x to the third, and we have positive 4x to the third. Those combine to be equal to
7x.
very good. 7x to the third. Again, addition won't change the variable's power. After x to the third, we should have what term next? X to the what? Good. All the x squares should be combined next. So let's go ahead and put squares around the squares. So we have 2x squared. And what's the other one? That's it, huh? So that one doesn't change. It just drops down, becomes part of the answer, 2x squared. Okay, now we have x to the third, x to the 2. What comes next? X to the first. We're going decreasing order of our powers. So we have how many x terms, x to the 1 terms? There's 2 of them, right? The first one is negative 5x. What's the other one? Positive 2x. Combine those, what do we get? Very good, negative 3x. What's not marked, maybe we should put triangles around them, is what are those terms called? The constants terms, right? This 7 and this minus 3 don't have variables, so they're the constant terms that could combine together to make what?
4.
Positive 4, so plus 4. Always check at the end, are my powers in decreasing order? 3, 2, 1, none. They are. And also double check, can I simplify anything else? Is there anything else that matches? No. So you can't simplify any further, and you are in decreasing order of your powers. That's your final answer. All right, so another way to add or simplify polynomials is the thing called the vertical method or a column method. What you need to do is line up your 2 polynomials, stack them in standard form order, and then combine them together. All right, so we're going to line up our polynomials, stack them over each other in standard form, and then combine. I didn't add that in there. Let's put that there. When we line them up, we're putting them in standard form. Why is that important? So our answer will already be in order. Very good. All right, just like the horizontal method, nothing changes these polynomials. We have invisible positive ones on the outside that would not change the values on the inside. So I'm going to go ahead and rewrite the first one as without parentheses. So 10y squared plus 8y plus 6. For the second one, I'm going to write it underneath the first one. I'm going to take this binomial and write it underneath the matching terms of the first one. So where will I put 17y squared underneath?
10y squared.
Very good. I'm going to put underneath 10y squared. That matches. They're lining up in standard form. The next thing I have to put is the negative 11. Where is this negative 11 going to go? Very good. Not under the 8y, but under the positive 6. What we're going to put in the middle there is a missing term. I want you to put a thing called a placeholder. Okay, put it in that different color there. This, let me label this as a placeholder. This will help you not make a mistake when you're adding up the columns here. Okay, this will keep you from adding diagonally. All right, so add straight down all 3 columns to get your final answer. Okay, so I'm going to draw a line. We are adding these together. 10y squared plus 17y squared is 27y squared. All right, 8y plus 0y is
8y.
still 8y. And then our last thing, the constants add up to be what?
Negative 5.
-5. 6 plus negative 11 is -5. Can I simplify that further?
No.
No. Can I rearrange it, or is it already in order? It's already in standard form order. We have our largest variable power first, 2, and then 1, and then y to the 0. All right, let's circle it. But before we move on, let's talk about how we can describe our answer. All right, so someone tell me a thing we could say about our answer, a description. Yes. The degree. The degree. What is the degree of our answer here? 2. We know that's because that's our largest power in the whole polynomial. All right, it's another thing we could use to describe our answer. Yes. The constant term. Wrong color. There we go. The constant term. What's the constant term equal to? Very good. -5. -5. Remember, it's a constant if it doesn't have a variable. All right, give me another thing to describe this. Yes. The leading coefficient. The lead coefficient. And what is our lead coefficient here? 27. 27 is always the coefficient with the that has the degree or the variable with the greatest power. Okay. What's another thing we could say? The name. What are you gonna name this, George?
Yes.
No, it's a trinomial. Very good. Trinomial. And in order to get that name, how did you figure that out? The number of terms. The number of terms. Okay, we have 3 terms. That makes it a trinomial. A degree 2, it's our largest power. Lead coefficient is 27. And our constant term with no variable is -5. All right, I'm going to do this problem using matching terms of the horizontal method. All right, my biggest x power is 2x squared. I see 2 of them. I see a 4x squared and a positive 1x squared. Those combine to make 5x squared. after x to the 2, I would have x to the 1, and there's only one of those. That's negative 3x. So minus 3x. My constants of 3 and 5 combined, probably shouldn't use circles there. Let's use underlining. Make those match to make 8. My trinomial is 5x squared minus 3x plus 8. What's the leading coefficient? 5. What's the degree? What's the constant?
8.
Number of terms?
3.
You guys sound so enthusiastic. All right, polynomial subtraction is just addition in disguise. That's all it is. We're still simplifying by combining like terms. But make sure if you have numbers now outside parentheses, positive or negative, make sure you distribute all those inside your parentheses. And then combine like terms. It becomes an addition problem. All right, so I'm going to show you the horizontal method first on this example. And then using the same example, I'll do the vertical method too. All right. Just like addition, polynomial addition, we're trying to simplify. And to simplify, we want to get rid of our parentheses. So our first polynomial has that invisible 1 on the outside, and we know that won't change anything. Almost made it. There we go. So that would be still 2x to the third plus 8x squared plus x plus 10. Nothing changed. But on the next polynomial, the trinomial here, what's on the outside is this negative. Yeah, that's a negative 1 in disguise right there. So we're going to take that negative 1 and distribute to all the terms on the inside next to it. So that changes all the what? The signs. It changes all the signs, all the values. Yeah. It becomes from a positive 5x to a negative 5x squared. From a negative 4x to a positive 4x. Because a negative times a negative is positive. Negative 1 times 6 is negative 6. Now we play the matching game. Combine all terms that have the same variable and power. Starting with what term though? The term that has the largest exponent, power. Very good. So what is my largest power in all of this here? 3 is my largest power. Are there any x to the thirds other than this one? No, that's the only one. We're just going to drop that down below. Okay, in fact, I'm going to cross it off. That way I don't get confused as I add up the other ones. Okay. Let me move this up a little bit. All right, now the next thing that comes after x to the third is the x squared term. Very good. How many x squared terms do we have?
2.
We got 2 of them. We have 8x squared. Very good. Negative 5x squared. Try to use squares on squares. Why not? What's 8 plus negative 5?
3x.
3x squared. Remember, the variable's power is not changing. Next is going to be the x to the 1, which will be 5x. So 1x, or x, plus 4x makes 5x. Our constants is the 10 and the negative 6. Combines to be what?
4.
Positive 4. Can I simplify any further?
No.
No. Is it in order?
Yes.
Yes. 3, 2, 1, none. If that's true, that's your final answer. All right, for the vertical method, just like addition, we're going to take the second polynomial and put it underneath the first one, showing subtraction though. All right, so our first polynomial is 2x to the third plus 8x squared plus x plus 10. That's our previous example. Now we're going to show, though, we're going to subtract the second polynomial, which is 5x squared minus 4x plus 6. But there's a missing term there, so let's put a placeholder to remember not to put anything else there. 0x to the third. Now, the big trick on this, the big mistake that happens is you're going to forget that you're subtracting an entire polynomial. You're not just subtracting 5x squared. You're not just subtracting 5x squared. You're subtracting this entire thing from what's above it. So when we get to this part here, it's really x minus negative 4x. What would that really be then? It would be 4x, right? Positive 4x. It's really not 10 plus 6. It's 10 minus 6. So what we have to remember to do is change the signs before you stack it. Okay? Because we're not taking away just one of those terms. We're taking away the entire polynomial. So basically what we have to remember is to distribute that negative and then combine in our columns. Let me rewrite that. So I distribute the negative and I rewrite it underneath. Well, we can't have negative 0. So it's still a placeholder of 0x to the third. But the next term becomes negative 5x squared. Okay, the next thing we multiply into is the negative 4x to make it a positive 4x. And the last one will be a negative 6. Okay, so after we take care of the negative, we combine. Combine means what operation? Addition. We are doing subtraction in disguise with these negatives. All right, so let's add up our columns. Okay, 2x to the third plus 0x to the third is 2x to the third. Okay, the next column adds up to be what? Positive 8x squared plus negative 5x squared. Positive 3x squared. We have x plus 4x to make 5x. And 10 plus negative 6 is 4. You can see we got the same answer we did versus the other method. So you could choose whatever method that makes more sense to you for that problem. Okay? So don't forget, if you use this method, the vertical method, remember to do what first? Distribute. Distribute and then combine. Okay. All right, number 1 here, we have a binomial minus a binomial. Don't forget to distribute what first? The outside things, right? This negative right here, negative 1. We'll change that to be minus 3x minus 2. The first binomial does not change. And now we play the matching game. What matches? 5x and negative 3x. Those combine to make what? 2x. And then my constants, negative 4 and negative 2, get more negative, be negative 6. 2x minus 6. The binomial with a degree of 1. Degree 1. All right, number 2. Okay, again, take care of the parentheses. Get rid of these. First ones, there's an invisible 1 outside, won't change anything on the inside. But this negative 1 will change those signs. Okay? Double check your math on the calculator if you need to. Negative 1 times negative 2 is positive 2y squared. Negative 1 times negative 3 is positive 3. Now we got rid of the parentheses. Now we're going to play the matching game. But what should we go first with? What's our biggest variable term? Variable exponent? 2. 2. We have a square here and a square there. Those will combine to be what? 10. And I realized I was supposed to do the other method now. All right, we'll finish this one though. All right, there is no other y term, so negative 3y stays there. But my constants will combine to be 9. All right, now let me show this vertically because I did say I would, and I didn't. Okay, I could jump from here into the vertical addition. So again, the first polynomial, and then I'm going to distribute and rewrite at the same time. Distribute and put that 2y squared underneath 8y squared. Distribute the negative 3 and get that positive 3 underneath the 6. There is no other y term. Don't forget the placeholder there, 0y. After we do that, we combine our coefficients by adding these numbers. 8 plus 2 is 10, y squared. Negative 3 plus 0, negative 3y. And 6 plus 3 is 9. Same destination, different way getting there. May the math be with you.